Hello, welcome back. Today we are going to analyze graphs and tables of quadratics. Feel free to use your Calculator x84 app to follow along. You're not going to need it today, but it's definitely helpful to be familiar with a graphing calculator. First of all, how are you feeling today? You can use these emojis to help you. Awesome. So we're going to start with a roller coaster problem. Notice the four letters A, B, C, and D. We have the height in feet. Which letter is at the highest point of the roller coaster track? Yeah, that's going to be B. What is the maximum height of this roller coaster? In order to do that, notice that the height is going to be on the vertical axis, also known as the y-axis. So you go to your highest point here, which is B, and you just read across. So I can say that that would be 50 feet. Which letter is at the lowest point of the roller coaster track? That would be C. What is the minimum height of this roller coaster? Solve this the same way. You find your low point, read towards the height, and we will get 10 feet. So we talked about minimum and maximum. If you didn't already know, the minimum is your low point and your maximum is your high point. So I'm going to bring this back to quadratics, also known as parabolas. These graphs right here that look like a U or an upside down U. We can tell a lot of things from this graph. For example, we can tell the zeros. The zeros are where your graph touches the x-axis. So what would those two zeros be? Well, one of them is going to be +1. The other one is going to be -1, -2, -3, -4, -5. Our axis of symmetry, that's going to be the equation of the line that goes right down the middle. So I just have to find the middle point of my graph, draw a line all the way down until I hit that x-axis, and it's going to be that x value. To find that x value, I start at 0 and I count twice to the left. So what would be my axis of symmetry? X equals -2. This is -1, that would be -2. Now something else that we can tell from this graph is whether it has a minimum point or a maximum point. And here's how we do that. We look for the middle point of the graph, which is right here. We have to ask ourselves, is this point the highest or the lowest point on the graph? What do you think? So because our middle point is the highest point of the graph, we would say that this has a maximum. It has a highest point. You might be thinking, wait a minute, there's low points. But if you look at the bottom of this graph, those aren't points. These never stop. They're infinite. They go on forever. So you're never going to find a low point of this graph. You will be able to, however, find a high point. This is called a parabola. You might also see this referred to as a quadratic. It's just a graph that's shaped like a U, either the right way or upside down, and it has a special point in the middle called a vertex. Now your vertex can either be on the top of your graph or on the bottom of your graph, but this is a sort of new word for us, the vertex. It's our middle point. We're going to be looking at that a lot today. don't worry, we still have the points that we've already learned. We have our zeros. But let's take a look at what else parabolas have. So let's say we were asked to graph a parabola. I already know that this is going to be a parabola because of that x squared. Anything with an x squared or whatever letter squared is a quadratic, I'm going to get a parabola. So what I've done is I type this into y equals and I hit graph. Now when I hit graph, I get a nice preview of what my graph is going to look like. And now I'm going to hit second graph and get that table. Now I can't fit every single one of these points on my graph, so I'm just going to pick the ones that I can fit and plot these points. Eventually I'll have you graph these on your own, but for now just watch as I graph in front of you. My first point here is -5, -5. That's easy enough, so I go to the left and then I go down. So my first point be right here. My next point, -4, 0. Right there. -3, 3. And -2, 4. Now something's gonna happen. My next point is -1, 3. You'll notice that there's a little turn. I was going up, 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 and then all of a sudden my points started going down. And that always happens in a parabola. You change direction. You'll go up, and you'll go down, or the other way around. So something else to note, because you have your axis of symmetry, your middle line, it's going to be the same on both sides. So these 2 points should be on the same level, and that can make graphing a little bit easier. So my next point being 0, 0, I could have predicted that since it's going to be on the same level as that point. And my next point, 1, -5, and then I can't fit -12 on the graph. So I have some dots here. I'm just going to do my very best to connect these dots. And then at my vertex, I make a little curve and graph all the way down. You want to make sure that there's a little curve. You don't do like a straight V like that because that's a different kind of graph. Now I want to show that my graph goes on forever and ever. So what can I put there to show that that graph would keep going? Yeah, I want to put arrows to show that that would be infinite. So this is how you graph a parabola. You'll maybe have some zeros. You'll have your vertex, and this would be a maximum since it has a high point. Okay, so just to review, if you have a parabola where the arrows are pointing upwards and there's a low point, you're going to have a minimum. If you have a parabola where the arrows are pointing downwards and you have a high point, you would have a maximum. Min meaning minimal, meaning small, max meaning big. So let's look at 3 examples and choose minimum or maximum. So let's look at this first parabola. Would you say that this first one, I'll zoom in here, has a minimum or a maximum? This is going to have a maximum because the vertex is at the top. Let's look at the next one in the middle. Would you say that this parabola has a minimum or a maximum, and why? This is a minimum because the vertex is at the bottom. Let's say I didn't hit graph and I hit table to look at the table. I can actually tell what's going on here just by looking at these y values. So just like in a parabola, you have your axis of symmetry and it's the same on both sides. The same thing happens in a table. You want to look to see where the numbers repeat. You want to find the middle. So right now, I'm just going to focus on my y values. Looking at my numbers here, which number is right in the middle? Well, that's going to be 3. This one is right in the middle. So if I'm trying to decide if that's a minimum or a maximum, I just have to look at the numbers around it. Would you say that 3 is the highest number here, or is 3 the lowest number here? 3 is the highest. It's higher than 1, it's higher than -5, it's higher than -15. So because this 3 is the highest, this is going to be a maximum. If I was going to graph it, that point would be at the top and all of these points would be below it. So that's how you can tell minimum and maximum from a table. You look for the repeating numbers. Makes kind of like a rainbow pattern if you draw. So sometimes you get a trickier looking parabola where you'll have a table that doesn't give you an exact minimum or maximum. Here's what I mean. If I'm looking for the repeats, well, I see that -3 repeats with -3, 1 repeats with 1, but now I have 2 numbers in the middle. If I was to actually graph this, my graph would look like this, where I have points at 4 and 4, just like in my table here. Now, the maximum isn't going to look like this, where you have a straight line and then it goes back down. You're going to have that curve that we were talking about. So we can assume that the maximum is just a little bit higher than the numbers in the middle. So if you ever have to assume what the maximum is in between 2 numbers, I would say just add a 0.5 or something, a number just a little bit higher than 4, and this can be your estimation if that comes up. Okay, let's look at 2 graphs. Which graph has a lower minimum? Which one of these graphs has a lower minimum, and how do you know? Is it k of x or f of x? Well, it's going to be k of x. This minimum is -2. If I was to count here, I would have 0, -1, -2. This minimum is +2. So I can say k of x because -2 is smaller than +2. Let's look at 2 tables here. Which graph, G or H, has a lower minimum? Just to remind you, I find my minimum by looking at the repeats. So 4 repeats with 4, -3, -3, -8, -8, -11, -11. So that would be my first minimum. And doing the same thing here, finding my repeats, that would be my second minimum. So be careful here because they're negatives. Which graph, G or H, has a lower minimum? That's going to be graph G of x, because if you remember the number line, negative numbers actually get smaller the further away from 0. So if I have 0, I would have -8 here and -12, and those would be your smaller numbers to the left, and these would be bigger because you go towards the positive. So let's look at a simple graph here. I'm looking for the equation of the axis of symmetry. So just to remind you, I'm going to draw my line through there. What is the equation of the axis of symmetry? Well, that's going to be x equals 2 because it goes through that x value. Now let's take a look at the vertex. I'm looking for an x and y. What are the coordinates of that vertex? Well, my x value is 2, that's on the x-axis, and my y value is 1, so that would be 2, 1. Now let's decide. Does this parabola have a minimum or a maximum? What do you think? Is that point a minimum or a maximum? Well, that's going to be a maximum because it is the highest point. Let's try another one. I'm going to try not to help you as much on these. What is the equation of the axis of symmetry? That would be x equals 3. When you draw your axis of symmetry, it goes through that x value right there. What are the coordinates of the vertex? That's x and y. My vertex is right there. The x value is 3. The y value is -1. Is this a minimum or a maximum, and how do you know? This is a minimum because it has a low point. Okay, let's try this again with a table. So what is the equation of the axis of symmetry? You can actually tell all this just from the table, but I'm going to go ahead and graph these points just to make it a little easier. So my first point being 0, 4. The next point being 1, -1. And then 2, -4. 3, -5. Then I make my turn, 4, -4. 5, -1. And then I have that other one cut off there. We actually don't need it. So I connect my points best I can. The equation of the axis of symmetry. What would that be? Well, that is x equals 3. What do you notice about the table? So I'll help you out here. I see my repeats. I notice that -5 is in the middle. I also notice that 3 is in the middle. So it looks like when I'm looking for my axis of symmetry, all I have to do is look for the number in the middle, and whatever x value goes with that number is my axis of symmetry, because symmetry means middle. So I did not need that parabola at all to be graphed. I could have figured this out from the table. My vertex is the point in the middle. The x value is 3. The y value is -5. So the vertex is just that point in the middle. 3, -5. The minimum or the maximum. Well, looking at the graph, I can see that I have a low point. So it'll be a minimum, but also -5 is in the middle. -5 is smaller than all of these other numbers here. These numbers are going up. So -5 is the smallest. So this would be a minimum because you could even say -5 is the smallest y value. Let's try this from a table without a graph. What is the equation of the axis of symmetry? It's going to be x equals, and symmetry means the middle. So remember, to find the middle, look for your repeats until you get down to the middle. So what is the equation of the axis of symmetry? Well, that is going to be x equals -1. I do that by finding my middle numbers all the way down to 9, and the x value that goes with that is -1. What would be the vertex for this table? The vertex is -1, 9. 9 is in the middle. Your vertex is your middle point. this is a tricky one. Is this going to be a minimum or a maximum? And how do you know? This is a maximum. 9 is in the middle. It's the highest point there. 9 is the highest y value. Let's try another one. What is the equation of the axis of symmetry? That will be x equals 4. We find our middle. That's 3. 4 is the x value attached to that middle number. What are the coordinates of the vertex? That'll be 4, 3, because that is right in the middle. Would this be a minimum or a maximum, and how do you know? So this is a minimum because 3 is the smallest y value here. Let's do another one. This one has a graph. What is the equation of the axis of symmetry? Well, here's how you solve that. You draw your axis of symmetry through that middle point, through that vertex, and it goes through that x value, which is -2. Now that I have that, finding my vertex is going to be so easy because I already know what x value is right in the middle. It's going to be -2. I just need to know my y value. So I'll have to do a little bit of counting, but that's okay. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my vertex. Is this a minimum or a maximum? Well, this is going to be a max, and you can say because the vertex is at the top of the graph. Now a throwback question, what are the zeros of this parabola? Well, that's going to be -1, 2, 3, 4, 5, and +1. Okay, here's a Regents question. I modified it a little bit. The original just gives you the graph, but I know a couple of you weren't able to download the calculator app, so I have given you the table of that graph right there. So it says the quadratic functions r of x and q of x are given below. The function with the smallest minimum value is, let's see if you could do this one on your own. So here's how you solve this. I need to find my minimum value, so I look for my repeats. So the minimum value for r of x is -16. And for q of x, I find my repeats. Min is -9. And it's tricky with negative numbers. The bigger the negative, the further from 0 it is, the smaller it is. So r of x is going to have the smallest minimum. So anything that says q of x can go away. And that minimum is -16. That one was tricky. Okay, let's try, I think this is our last one. Which of these quadratics to the right has the smallest minimum? Be careful when you're counting on the graph here. Okay, so to find the minimum of each one, you got to find in the table the repeats. So 10, 4, 0. Oh, I have 2 in the middle, so I'm going to assume that that's about -2.5-ish, because there's 2 in the middle. I know it's a little bit more, or a little bit less in this case, the minimum. So I guess next to choice 3, I'll put negative 2.5, and then choice 4, finding my repeats, negative 6 is right in the middle there. And then here's my minimum. I just have to count down to that. So this would be 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. That would be negative 10. So choice 2 would have my smallest minimum since it is at negative 10, and that's the smallest negative out of all of these. So that's it for today. Next time we're going to practice graphing. I hope you enjoyed this lesson somewhat, and just let me know how it went for you.